Hello everyone, thank you for making it. I'm Michael Fudge and I'm glad you're here for our series on mastering the SQL SELECT statement. In this fifth installment in this series, we will take an in-depth look at table joins. This should be a good one. As always, you're encouraged to follow along using the Learn Databases environment. Follow the link below, applydb.com, for details. In this video, we're going to emphasize the join clause, which is part of the from clause of the select statement. Specifically, we're going to look at basic join syntax, multiple table joins, the outer joins, that is left, right, and full joins, and we'll take a look at doing null checks across joins and then self joins. It ought to be a good one. Let's get going. All right, here I am out here again in Azure Data Studio, and I will be mainly focusing on the TinyU database, which is part of the Learn Databases environment. Right now, we're going to start with students, but eventually we will touch all the tables that you see over here on the left. So when you look at the student table, you'll see there's a column here called Student Major ID, and that doesn't really tell us much about what everybody's major is. Like Aurora Borealis, it says her major is a 1, but I don't know what a 1 is, do you, right? So let's take a look at the majors table. In the majors table here, we see that major 1 is this one here, information management and technology. And major 2 is applied data science. And major 3 is accounting. So how do we show what's in this table and what's in this table up here together in one SQL output? Well, the answer, of course, is the join clause. Basically, the way it works is you have a column in each table that you're going to use to match values. So every time I see a 3, I'm going to match it to this row here because this ID has a 3. Every time I see a 2, I'm going to match it to this row here. And that's basically the essence of what's called a natural join or an equijoin, okay, where you join where two columns are equal. So let's write that now. And I'm going to be very specific about the columns I use in my projections just to keep things simple and small. So let's do this. Let's set that up, and then I'll end up copying that across various examples. So let's do select student name. Student first name as student name. And then let's add in student year name. And then let's add in student major ID, just so that we can see how the join is working. And then from the other table, I want to add in major ID. See that? I'm going to add in major ID. And I'm going to add in major name. And now I have to include the other table. So I say from students join majors. And then I have to say how I want to join them together. And I want to join them on the condition where the student major ID is equal to the major ID, where this column here, values in this column equal values in this column. Okay? Let's run it. Okay, and you can see now that this student here is an applied data science major. This student here is an information management major. This student here is an accounting major. And I left these two columns in here to give you confidence to know that it is matching them correctly. Because you can match these on just about any condition you want. And a lot of times it won't make sense when you do that. See that? I'm joining these based on where the major ID does not equal the student major ID, which doesn't make a lot of sense, but you can join these really any way you feel like joining them. But that doesn't necessarily imply that it makes any sense or has any rhyme or reason to what it is that you're doing. So 99.9999999% of the time you want to join these together where they match, and that is an equijoin. Like that. Okay, so now that I have that, I'm going to take out these major IDs. I'm going to we're going to continue on with this example. Let's add in GPA and sort by year, then GPA. Okay, so I'm going to take out these major IDs, and I'm going to add in the student GPA. And then I want to sort the student year name, and then the student GPA after that. And I'll sort that second one descending. So the higher students, the higher GPAs occur first. So then I get my output, Robin Bank. Oh, Bank's Robin. I got to fix that. It should be student first name here. Should have fixed that before. And then student last name here. So I have Robin Banks, freshman, got a 4.0 in accounting. Cook My Food, freshman, got a 3.5, applied data science. What I don't like about this output is it doesn't go freshman, sophomore, junior, senior. It goes freshman, graduate, junior. It's sorted alphabetically and not sorted by actual rank. So in order to sort it by rank, I need to include the year names table. And from the year names table, I need to include the sort order so that I can sort it in the proper order. So to sort of set the stage here, what am I joining on? I'm joining student year name on the year name column. So when you want to add more than one table to the join, you just keep adding to the join clause. So you say join another table. Let's join year names on student year name equals year name. Okay, now when I join them, I can include up here the sort order, and then I can order by the sort order. And now I get freshman, sophomore, junior, senior. Why does this work? Because I have a column in this other table, year names, that says freshman is a 1, sophomore is a 2, junior is a 3, senior is a 4, and graduate is a 5. And then because I have that in there, and sort by this column, they now sort in the order that I wanted. So that's the magic that works. Now that I know that it works, I don't have to include sort order in here. I don't have to see that. I can certainly order by it without seeing it, and then that gives me what I want, which is a nice report of student name, year, their GPA, and their major. Okay, it's basically where we're at. Now, there's a couple things worth talking about at this point. So let me come down here and let's talk about table aliasing. So I'm going to take this same example from before, because you certainly don't want to see me typing all this code again. And let's talk about table aliasing. When you have multi-table joins like this, it's usually a good idea to start to think about aliasing your tables. And what aliasing your tables means simply is to give it a name. So I could say students as S, and then I could say majors as M, and year names as Y. And then I can start to qualify all of these columns. So this would be S dot student name and S dot student last name. This way you can easily look at the query and know where things come from, right? So student year name, S dot student year name, student GPA, S dot, and then major name comes from the majors table, M dot. Right? So now I look at this line here, lines 20 and 21, and I have an easy indication of where everything is sort of coming from. Which table? In my joins, I should fix this too. So student major ID, that would be from the S table, and then major ID comes from M. Now, I have set up these tables so that the column names are very friendly, but a lot of times in real databases, it's just called ID. It's not called student major ID, right? This one might be called major ID from the student table and then major ID from the majors table. And so you don't know which one's which. So you need to use this table aliasing in order to make sense of it. But these tables were nicely crafted for your easy querying pleasure, and that is not usually the case of what you will see in tables in real life. The other thing I want to mention about what you see here is remember the order of processing. The very first thing that happens in this statement, in this select statement, is the from clause happens. So the first thing that happens is we make one big fat table from the from clause. So if I was thinking about this in terms of order, it would be select. Step one is this. Okay, we get step one is we get this. You get that. Step two is we do the where, which we don't have. Step three is now we project. So step three, we add in this projection, and then we only get these things. And then step four is we take this and we sort it. So that is pretty much the basis of how the query gets processed. It's important to remember that. So that is multi-table joins. Let's do another example. Let's do what's called an outer join. So maybe you want to show all majors, even those without students. So for example, if I take a look at that majors table, when I take a look at that majors table, there's a major here called basket weaving, number 5. And if I look at all the students, I don't know if there's a student that has that major. If I look through here, I don't see any 5s in there. So the question is, when I join these together, as I did up here, you'll notice that there isn't a single basket weaving major represented here. You might want basket weaving to still appear in the query output. Okay. So to do that, you have to introduce what's called an outer join. So let's just do this. Let's alias majors as M and alias students as S. And one of the nice things about aliasing is I could do this. Show me all the majors, M dot star. From majors, join students S on S dot student major ID equals M dot major ID. I'm going to do this, get this started. And this is only going to show the data from majors. But we get all these rows because each one of these rows is also a student, right? Each of these rows is also a student. And so, like, for example, if I include maybe the student name, student first name, last name, you can see who the student is that has those majors. So this accounting major, Robin Banks, right? And then I might order it. Major ID. Okay, we'll take a look at this. Maybe I should be consistent here. M dot major ID. That's great, but you'll see that nobody has a basket weaving major. So I want basket weaving to appear, and I want it to show that there's no student that has that major, because when you leave it off the report, you have to figure out yourself whether or not someone has that major or not. Right? So the way you do that is with what's called an outer join. So in this case, the table on the left of the join, if I look at my join statement, let me rewrite it like this. The table on the left, I want to include every single row from that table. So I do what's called a left join. Okay, this is called an outer join. Okay, and now I will see every single major and students with that major, and I will see one last major, and it'll have nulls because no student has that major. But now it appears on my report, and that's kind of what's important, right? When you leave the left out, you see all the students and all the majors, but you don't know which students aren't even using that major. This at least tells you a little extra information. It tells you which students are not using that major. Okay. So with outer joins, you can do what are called a null check, so that you can find only the major that has no students in it. So if I can take this same query, and this is only majors with no students, I introduce my left join, and then I have a where clause where I check for the student ID, right? You always check for the primary key in the table on the other side of the left, on the right side of the left join, and you check for null, because that means there's no student. It should be S student ID, Mike. There. And now I get just the major that has no students in it. That's a left join. Now, you can also do a right join by changing the word left to right. And a right join is the same as a left join. It's just the table that includes all the rows is the table on the right. So it doesn't really matter. If you said students left join majors, it's the same as majors right join students, because the left and right is relative, right? So in this case, right refers to this table, left refers to this table. Okay. So let me write another query with an outer join to show only students with no selected major. So I need to include all the students, including those without a major. So I could use a left or right join. It doesn't matter. I just need to make sure that if I do a left join, student table's on the left, because that's the one I want, right? I want to find students without a major. If I put students on the right, then I got to use a right join, right? So let's just write this. I'm going to say select star, and let's build our join first from, I guess I'll put students on the left, students as S, left join majors, left join majors as M on student or S dot student major ID equals M dot major ID. And let's put all the students in here. And then we're going to say where the major ID is null. That means that student has no major. And then we are going to query that. And there's one person, Michael Fudge. Okay. And so that's how you use outer joins. You use outer joins mainly to include not only values that match, but also values that don't match. Okay. That is the purpose of a outer join. There's also something called a full outer join. And a full outer join will include rows from both tables where there is no match. So let me give you an example. So maybe I want to get a report that shows students and majors, okay? And I'm just going to copy this because you've seen me write the join now about 10 times. And I'm going to take out everything. I don't need the aliasing because I'm just going to throw the, I'm just going to give it all. I'm going to give it all. So these are all students and majors. Okay, and there are 30 of them. But you know who's missing? Mike Fudge, because he doesn't have a major. You know who's missing? Basket weaving, because no one's in that major. Maybe I want to include those both. That's where the full join comes into play. Full join says take every physical row from the left, every physical row in the right, even the ones that don't match this criteria in the join. So before we had 30, now we should have at least 32, right? Because there is now the original ones, and then now there's Michael Fudge as a grad student who's undeclared, and then there's also no student in basket weaving over here. You see that? So now you can see like where the nulls come into play. Why are these nulls? Because I don't have a major, so there's nothing to find me in the majors table. Why are there nulls over here on the left? because, well, there's no basket weaving student. There's no student in that major. Now let's talk about the last example, self-join. Now to do a self-join, there's no data that I can use in TinyU to do a self-join. So I'm actually going to use a different database. I'm going to use payroll database. Let's switch over to that database. Now we're in the payroll database. And in payroll, there is a table called employees. And in the employees table, there is a column. There's an employee ID. Makes sense, right? And then over here, there's a column called employee supervisor ID, right? So, for example, this employee here, Amber Waves of Grain, her supervisor is employee number 1, which in turn is Michael Fudge. Okay? So maybe I want to build a report that lists the names of the employees and then the names of the supervisors. Okay, seems easy to do. I have to join the employee table twice. So when you join a table to itself, this is the self-join example. Self-join example. You will need to add the table twice. So I'm going to say from employees, join employees, which looks weird. And because I add the same table twice, I need to alias the table. There's no ifs, ands, or buts about it. I have to alias the table. That's the way it works. Let's go ahead and give this a try. Now, first thing is let's not show all this data. It's too much data. Let's just do employee first name plus employee last name as employee name. And let's add the employee ID for reference. Okay. Now, from employees, let's join employees again as supervisors. Oh, man. I'm just going to go with soups because I can't spell supervisors this morning for whatever reason. And let's join them on employee ID on the supervisor's employee ID equals the employee supervisor ID. Okay. Now you'll see it's still complaining, and that's because you really can't alias one table without aliasing the other. So I have to say as emps here or something. And now I can say emps employee ID, emps employee first name, emps employee last name, and then emps. Now, I'm going to run it like this for now. So what you're going to get is just going to get a list, the same list of employees we had before. There they are. Okay. And what I want to do is I want to put their supervisor next to them. So now putting their supervisor next to them is pretty easy. If I just do this, and let's say emps, for reference, let's do this. Employee supervisor ID. And then let's also add in here the supervisor employee ID. And then we'll add in the supervisor's first name and last name. Like this. And I'm just going to copy it so you don't have to watch me type it. Soups, first name. Soups, last name. And then this would be the supervisor. Hey, I spelled it right. Okay. So we're going to have the employee ID and name and the supervisor ID and name. So Amber Wave of Grain, that's her supervisor is 1. 1 is employee ID 1 from the supervisor's table, and that's Michael Fudge. And then Lisa Carferless, her supervisor is 3, and 3 just happens to be Joy To The World. Right there. So it does work. Now, you'll notice that there's one person missing. Employee ID 1 is missing. Employee ID 1 is missing because employee ID 1 does not have a supervisor. So in this case, we need to use an outer join to guarantee that that employee shows up here. So let's think about this. We want to show every single employee, even the ones without supervisors. So that ends up being a left join, right? I want every employee, even the ones without supervisors. Okay, that should give us what we want. Let's try it. Oh, there I am. See, I don't have a supervisor, so you still want me to show up. Right? I'm at the top of the management pyramid, as we joke around. Okay, well, that's joins in SQL. And I think the biggest moral of the story that I can share with you is this on clause. You can make this on clause say anything you want. It doesn't matter. But most of the things that make sense are going to be equals. And these columns here on the left and right, they should be compatible columns. So I will leave you with this example. If I go back to tiny u again, and because it's small and we can make sense of it, and I select students again, and I select from majors, and I show you these columns, there's nothing preventing me from joining these two tables on like this. There's nothing preventing me from doing this. The only problem is it doesn't make any sense. Let me show you. What this is saying, in essence, is that student number 1 gets matched up with major number 1. Student number 2 gets matched up with major number 2. You can write it. That doesn't mean it makes any sense. Okay, and this is actually the danger of the SQL language, is you can do a lot of things that produce a result so it appears to be right, but unless you vet what you're actually doing, you are actually showing irrepresentable data. That is data that doesn't make any sense. It doesn't coincide with the business rules. It is nonsense, right? So someone might be tricked into thinking that this Robin Banks is in information management when really their major is 3, which is accounting. And that's all because we didn't join correctly. And again, this is the biggest challenge of SQL. It is not understanding what to write, or I should say how to write a join. It's what do I put in here? Okay, what goes where? Okay, and you can only know that answer by inspecting the data and understanding the data that you have, and then realizing, oh, okay, this column and that column go together, not student ID and major ID. You have to understand the schema, the underlying tables, and the way that those tables are going to integrate with one another. You can't just make an assumption that because one column says ID and another column says ID, that they belong together. Okay, and that's where you get into serious trouble with the SQL the select statement, because you can make it show an output, but that doesn't necessarily mean the output is right. And it's really on us to make sure that we're showing correct output. Okay, so that's my final moral of the story with the join clause, is just because it works doesn't mean it's right. That is ultimately on you to make sure that what you're showing is right.